In this video, I want to show you how unit hydrographs work. And I'm going to do it through Excel. But I want to emphasize that the point of this isn't to show you how to make this happen in Excel. I'm just using Excel as a device that will quickly and easily allow me to change the input parameters and immediately see the output parameters. And that's basically the idea of a unit hydrograph. So let me show you what I'm looking at here. There's a bunch of different colors and numbers, and what I want you to concentrate on are the ones in blue initially, because that's the hydrograph that I've actually plotted down below. So actually, let me explain what you're looking at here. So there are two graphs shown. This upper one here that I'm highlighting now, that is the hyetograph, and it's a 6-hour hyetograph. So both the hyetograph above and the hydrograph below are using the same x-axis down here, the x-axis of the hydrograph, and it's in hours. That goes from 0 hours all the way to 60 hours on the right. And what I'm showing on the hyetograph is the 6-hour unit hyetograph. So in other words, what I'm saying is that during the 6 hours, there was a precipitation rate that resulted in one total, let's call it, inch of precipitation. So in other words, if it was 6 hours of continuous precipitation and every hour it precipitated at a rate of 1/6 of an inch per hour, after 6 hours, the area under this curve of the blue bar here would be 1 inch. And that's what's shown here in cell A1. That is the area underneath the blue hyetograph. And since it's 1, that's a unit hyetograph producing a unit hydrograph. So this is the hyetograph above here, and the hydrograph response of the stream at the outlet of the watershed is shown below in red. And you can see that it basically starts to climb right as soon as it starts to rain, and it reaches a peak real close to the end of the rainfall event, right close to 6 hours, and then it tapers off, finally ending at about 19 hours or 20 hours or something like that. That's the unit hydrograph. It's the hydrograph that results from an input of 1 unit of precipitation, in this case 1 inch of rain occurring over some designated time period, which in our case is 6 hours. It's a 6-hour unit hydrograph. Now, the reason unit hydrographs are cool is I can now answer the question by simply scaling this unit hydrograph. What if I want to know, well, what if not 1 inch of rain fell or excess rain fell, but what if we had 2 inches of excess rainfall? So up in A1, remember, that's the area under the hyetograph, and you see that it jumped up now. Now we have 2 inches of rain underneath this box, and notice how the hydrograph jumped up. Started at the same time, ended at the same time, but the peak is twice as high. Everything about it has been scaled up by 1. So once again, here is the the unit hydrograph, and here is the 2 units hydrograph, double the unit hydrograph. If I had 3 inches of rain, I would just scale it up even more. If I had only half an inch of excess rainfall in 6 hours, I would scale it down. So the hydrograph here represents the unit hydrograph scaled down to reflect the fact that I only got 1/2 of a unit, or 1/2 of an inch of rain during those 6 hours. So the idea is that by the hydrograph, the unit hydrograph graph, is scalable up and down depending on the input amounts that occurred during that 6-hour period for a 6-hour unit hydrograph. So let's go back to 1. So this is the unit hydrograph that's produced from 1 unit of rain falling in 6 hours, excess rain falling in 1 hour. Now, the second really important part, or the cool thing about a unit hydrograph, is that it is additive. So imagine, like I said, here is my unit hydrograph. What if, instead of starting, I want to think of another unit hydrograph that starts 6 hours after the first. So let's say I imagine the rainfall event starts 6 hours after the first, and it continues to 12 hours after the initial condition, right? So it starts at 6 hours, ends at 12 hours, and this is what it would look like. The area under this green, this is now the green one, okay? So you're looking at the green one. The area under this green hyetograph is 1 unit, and there's the hydrograph that responds. It's exactly the same way. The hydrograph always starts, in this case, right when at the beginning of the hyetograph starts the beginning of the hydrograph, and the end of the hydrograph is always 20 hours after the end of the beginning of the hyetograph. So this is exactly the same one, exactly the same thing as I had over here except it's shifted over to the right by 6 hours. Now, let's imagine I have a rainfall event that I have 6 hours of rain producing a unit hydrograph just like I've shown here, followed by another 6 inches of rain producing another unit hydrograph. There you go. So the first unit of rain results in the blue hydrograph. The second unit or dose of rainfall produces the green hydrograph. And now I'm showing the sum of those two hydrographs in red. So the red line represents the actual hydrograph you'd see at the stream. That represents the sum of the contribution during the first 6 hours, and then in blue, and the contribution in green during the second 6 hours. What if that first rainfall event, what if I only got half an inch during the first hour and I got 2 inches during the second hour? I just scale up those individual parts proportionally, and there's my resultant stream hydrograph. What if, let's go back to units, okay, 1 unit in the first 6 hours, 1 unit in the second 6 hours. Let's now add a third 6-hour period on the tail of those, another 6 hours of precipitation. So now the hydrograph shows 3 consecutive 6-hour periods of precipitation. The area under each of these, the blue, the green, and the yellow, is each 1 inch, if inches are our units. So the total precipitation that's fallen during now 6, 12, 18 hours is now 3 inches. And notice what I have in the hydrograph. The blue line represents the hydrograph that results from the blue rainfall event. The green hydrograph represents the hydrograph that's produced from the green rainfall event, and the yellow hydrograph represents the rainfall event from the yellow rainfall event, and the red is the sum of all three. And it's kind of a funny looking hydrograph because it's the sum of all three of those. And once again, I can also scale the individual ones here. So if I had 2 inches of rain during the first 6 hours, 3 inches of rain during the second 6 hours, and only 1 inch of rain in the third, I can very quickly, there's the hydrograph showing that, 2 inches during the first, 3 inches during the second, and only 1 inch during the third. Those are my 3 scaled unit hydrographs in blue, green, and yellow, and the red represents the sum, the actual hydrograph you'd see in the stream. That's the beauty of unit hydrographs. They allow you to both scale individually within one unit hydrograph if we change the intensity of rainfall or the amount of rainfall, and you can add them by connecting, by linking one unit hydrograph right next to another unit hydrograph right next to another unit hydrograph, and account for rainfall events that are longer than the time scale of the unit hydrograph. In this particular case, we're looking at a rainfall event that lasted for 18 hours, and we created that by linking together 3 separate scaled unit hydrographs of 6 hours.